Hello class! Last week, during our Thursday application session, we examined the internal construct validity of the perceived stress scale. More specifically, the convergent and discriminant construct validity of the items in our scale. Then we evaluated the internal consistency reliability of the scale items as a whole and as two subscales, which would be the proper thing to do, as we saw, because we identified two factors during the exploratory factor analysis. Now we will move on to examine the external nomological validity of the perceived stress scale, or the PSS-10 scale. To analyze external validity, we compare the PSS-10 scale responses to the responses of another construct or a variable in our dataset. The key here is to be aware of how responses to your PSS-10 scale are expected to vary with the responses to other constructs scale, to the other construct scale, or to other variables. In our example, the researchers had also collected data on a couple of other scales and several indicators that may be useful for this exercise. For example, respondents also answered a scale of 12 questions related to the General Health Questionnaire, or the GHQ-12. The GHQ-12 scale measures current mental health, and so higher scores on the 12 items correspond to poorer mental health. Based on the literature, the researchers expect that the perceived stress scale and the General Health Questionnaire are positively correlated. In other words, a respondent with a higher score on the PSS-10 scale will also exhibit a higher score on the GHQ-12 scale. Or another way of saying it, someone who perceives that they have higher stress levels will most likely show signs of mental health issues or distress as well. It is important to choose a comparison scale that exhibits good reliability and validity measures. And as you can see here, we include the specificity and sensitivity of the GHQ-12 Arabic scale. So the key message here is that when you want to compare two scales in external validity, you want to choose a scale that is stable and an accurate reference to conduct your validity check. So to measure external validity, the total scores of the PSS-10 items and the 12 items in the GHQ scale are added. Each one is added separately to produce a total score. After checking the distribution of the scores in the dataset, we choose the proper test to perform our correlation. Here, because the data is not normally distributed, we will use Spearman correlation, and you will see at the bottom of the slide, I have included the stata command to use. And here we see the stata output, which shows that there is a correlation of 0.629 with a p-value less than 0.001. This means that there is a statistically significant positive correlation between the two scales, and we conclude that this is in line with what we had hypothesized from the literature about the relationship and the external validity of the perceived stress scale. So the external validity of the perceived stress scale is verified. We can also measure the external validity by comparing our scale to a variable rather than to another scale, such as the GHQ. So in this case, we will compare it to a variable which measures or which collects data on living conditions. It asks about the ability of the family income to cover necessities. Therefore, respondents who have poorer living conditions should exhibit signs of higher perceived stress. To test this, we will use the independent sample t-test. Using the commands shown on the slide below, we should first check the assumption of equal variances among the groups. In our case, the assumption holds, and we continue to run the independent sample t-test with equal variances. In the output, in the first red box, so in the first red box here, we see the mean PSS-10 score within each category of our variable living conditions. Among respondents who identified that they never or rarely had enough income to cover life necessities, the mean score of the PSS-10 is 22.77. Compared to the mean score in the second category of 18.5 among respondents who find their living condition to be good. To see whether there is a statistically significant difference between these two groups, and it is not due to chance, we check the p-value with the alternate hypothesis that states that there is a difference between the means and that they are different and not equal to 0. So this is, we look at the p-value over here, and the p-value is 0.0083. Hence, we reject the null hypothesis that the means are equal and conclude that those who cannot or are hardly able to cover life necessities have a higher perceived stress score compared to those whose income can cover necessities. And this is in line with the theory, and external validity is once again verified here. Later on in this lecture, I will show you the results related to the scale in Dr. Shaya's article for the validation of the Arabic version of the perceived stress scale. But for now, I would like to show you an example where we measure criterion validity using a different data set. I want to note here that if there was a gold standard that we could refer to measure stress levels in humans, Dr. Shaya and her co-authors would have used this gold standard to measure criterion validity of the Arabic perceived stress scale. However, since no gold standard exists, the author chose to conduct the external nomological validity test. So to examine criterion validity, we will look at a data set that collected data on depression using the Center for Epidemiological Studies Depression Scale, abbreviated as CESD scale. This scale consists of 7 items with categorical responses for each item. Since we are measuring criterion validity, we need a gold standard to compare the CESD results to. Ideally, this would be a psychiatrist diagnosis. The CESD items, when added, give a continuous score ranging from 0 to 15, which means a spectrum of results and levels of depression, from 0 being not depressed to 15 being depressed. How well do these findings of the CESD scale correspond to a psychiatrist's diagnosis? To answer this question, we will need to determine which cutoff on the scale from 0 to 15 will best correspond to the diagnosis of a psychiatrist with the least amount of error. We will do this with the help of a receiver operating characteristic curve, or a ROC curve, using the following command. This is the generated output showing the ROC curve and a detailed table of the different cutoffs and their characteristics. Interpret the ROC curve. The ROC curve illustrates the trade-off between sensitivity and specificity. The closer the curve follows the y-axis sensitivity scale to the top and the specificity x-axis scale to the left, the more accurate the scale is. So if we look at our ROC curve, we want to identify the point which is closest to the top left corner. We want to identify the point which is closest to this point, and this is the point that is circled in red here. So at this point, sensitivity seems to be slightly over 0.5 or 50%, and specificity is slightly above 0.75 or 75%. And we can also read from this curve, we look at the area under the curve, or the area that is between the curve and the diagonal line. This is a measure of the scale's accuracy compared to the gold standard. In this case, it is 0.72, which is acceptable. Shows the ROC curve in the output. We refer to the point we had circled in our ROC curve to identify the corresponding cutoff and sensitivity and specificity of this cutoff. The cutoff that we identified from the ROC curve is a score of 6 over here. And this has a sensitivity of 56.25% and a specificity of 78.05%. So a sensitivity of 56% means that the CESD scale will correctly, positively identify those that are diagnosed as depressed by a psychiatrist 56% of the time. And the specificity of 79% means that using this cutoff of 6, the scale will correctly identify respondents as not depressed when they are truly not depressed at a proportion of 79%. Of course, you can choose other cutoffs and compare the sensitivity and specificity percentages for each. Keep in mind, though, that the sensitivity and specificity are inversely proportional. When one increases, the other will decrease. So the point we choose on the ROC curve shows the best trade-off between both based on the scale we are using. To illustrate better the relationship between sensitivity and specificity, I will use this illustration from the internet, which I will adapt to our example that we just saw now. In this figure, we see the distribution of respondents' scale scores on the CESD scale, our example. We have hypothetically set 2 scores because we have a gold standard and we know who is actually diagnosed as depressed. So this is the pink distribution. So we know that people who are depressed have a distribution of scores in the pink area, and who is diagnosed as not depressed in the blue response distribution, or the blue area in the graph. So on the x-axis, we will imagine that there is a scale from 0 to 15, which is the range of scores on a CESD scale. Respondents who are not depressed will answer the CESD scale items by choosing response categories that have a lower score. And when adding up their overall score, when adding all the item scores up, the overall score will be on the lower spectrum of the 0 to 15 range. In the figure, this corresponds to the blue area. So those who are not depressed will score lower on the lower range of the scale. The pink area illustrates the distribution of respondent scores of respondents who are indeed clinically depressed. Their overall scores will obviously be higher and closer to 15. You can see the 2 distributions overlap in the middle. So here we see that the distributions overlap. Some depressed people or respondents may respond in a way that to the scale that gives a similar score to someone who is not depressed, and vice versa. Here we can start to question how accurate is this scale if it cannot differentiate between the cases and the non-cases, or those who are depressed and those who are not depressed. Logically, the less overlap there is, the more valid the scale is. Next, we want to identify the cutoff of the scale that we did, similar to what we did earlier. The point on the ROC curve, which is closest to the top left-hand corner, is the dotted line B in this illustration here that I'm showing you. So this line B, which goes across the middle. This gives you the least amount of false positive, which is the blue area crossing to the right. So this blue area that's crossing to the right of line B, and the least amount of false negatives, which is the pink area that is to the left of line B. To interpret the false negative area, this is where respondents who are depressed based on the psychiatrist's diagnosis are misclassified as not depressed because we chose the cutoff B. If we move the cutoff line to line A, which is this line, in order to make sure that we do not have any false negatives and make sure that our scale identifies all those who are indeed depressed 100%, which is like saying that we want a sensitivity of 100%, what happens to the specificity? We move the cutoff line to the left to line A. Everyone in the pink distribution is correctly identified. But at the same time, we have identified a lot of non-depressed respondents as depressed, which is the whole blue area to the right of the line A. These are all false positives, which means that we have reduced the power of our scale to identify true negatives, or those who are not depressed, identified as not depressed by our scale, which will decrease the specificity of the scale drastically. In conclusion, criterion validity is verified when the scale is able to accurately identify cases and non-cases when compared to the gold standard for the construct which is being measured. I hope this has been helpful in helping you understand the relationship between sensitivity and specificity. And please don't hesitate to send me an email or ask me for any clarifications. So finally, I want to go back to the validation paper for the perceived stress scale. Dr. Shaya et al. Conducted a validation exercise for an Arabic version of the scale. And the aim of the study was to translate the perceived stress scale into classical Arabic and examine its psychometric properties. When we refer to psychometric properties, we're referring to measures of reliability and validity. To validate the Arabic scale, a sample of 268 women were selected. The sample was made up of pregnant women, women who had just given birth and were in their postpartum period, and healthy female university students. First, the authors had to translate the scale. And as you'll see here from the excerpt and from the summary points, it is not a straightforward step. There has to be rigorous, it's a rigorous exercise to correctly translate a scale and make sure that it is understandable. In the methods section, there is a thorough description of the other scales that were selected to measure external validity of the perceived stress scale. Valid Arabic scales were needed for this exercise, and so the GHQ, which we did the exercise on, was selected, as well as the Edinburgh Postpartum Depression Scale. Both these scales, after being translated to Arabic, were validated in the literature and they showed good psychometric properties. And so the authors chose to use them for the external validity exercise that will be done for the PSS-10. The authors described the reliability checks that were conducted in this section, as well as the validity measurements that were done. So there was the exploratory factor analysis, which started with the PCA to make sure that indeed there are two factors, followed by the orthogonal rotation, the Varimax rotation. And subsequently, they measured the external construct validity using the scales, the other two scales. In summary, the psychometric results are shown here, highlighted in blue. And the authors conclude that these results led to the conclusion that the Arabic scale was found to be reasonably adequate, to have reasonable, adequate psychometric properties.